Hey guys, welcome to question MM244 of the Maths Methods Fortify study guide. So in this question we've got a circle with radius 2 units and center at 0, 0, and it's drawn on an axis with a tangent QR to the circle drawn at point P, f of P as shown below. So we've got this graph here. Now part AI tells us to find M in terms of P, where M is the gradient of line QR. So we've got this line QR, which is a tangent to the circle, and we're trying to find its gradient. Cool. So the biggest thing about this is that we don't know the equation of this circle. If you do know the equation of the circle, that's cool. We can figure out the equation the gradient of the tangent using that. But let's actually do it in a way that you don't need to find the gradient of a circle because you're not really used to doing that. So we know that this is point O. If QR is a tangent to the circle, then that means that it's a normal to any radius of the circle, right? So the line OP is a normal to the line of QR, right? Because it's a tangent to the circle. So what we're going to do is create a triangle out of this spot here. And we're also going to then say that because this is a normal, the gradient of QR is the negative reciprocal of that. So the gradient of OP is equal to rise over run, right? So we've got this triangle where this is P, f of P, which means that our x value is just P and our y value is f of P, right? But we actually don't know what f of P is. But what we do know is that this circle has a radius of 2 units, and wherever you go in this circle, that radius is going to be the same, which means that this is 2, right? So this distance here is 2, that's 2, that's 2, all around the circle because it has the radius of 2. So that means that our f of P is, according to Pythagoras, so that a squared plus b squared equals c squared, which means that f of P squared is equal to 2 squared minus p squared, which means that f of P is equal to the square root of 4 minus p squared. Awesome. So that means that our rise is going to be root 4 minus p squared, and our run is going to be p, which means that MOP is equal to rise root 4 take p squared over run, which is p. And then because this is a normal to QR, that means that M of QR is equal to -1 over M of OP, which means we simply flip this gradient and make it negative. So then we get negative p over root 4 minus p squared. Awesome. So guys, our first mark came from recognizing that f of p was root 4 take p squared, and then our second mark comes when we actually find the gradient of QR. So that's it for part AI. Let's go to part AII. So part AII asks us to find the equation of line QR when p equals 1. So this is a 2-mark question. And we know that the gradient is going to be equal to negative p over root 4 take p squared. And how do we find the equation of a line? We use our linear formula. So y take y1 equals m outside of x take x1. We know this is going to be our gradient. And we also know that there is a point p f of p on this graph, which means that our point that we're going to sub in is p, and then root 4 take p squared. Awesome. So now we can simply sub all of these in. So y minus root 4 take p squared equals m, which is negative p over root 4 take p squared, outside of x minus x1, which is p. Awesome. Sweet. So from here, we know that we can kind of expand all of this out. So what happens is we get, actually, you know what, let's sub in our p equals 1. So the question tells us that we have to sub in p equals 1. So what we're going to do is take this equation and sub that in. So we then know that y minus root 4 take 1 squared, because p is 1, equals -1 over root 4 take 1 squared outside of x take away 1. Awesome. So from here we get y take away, so the square root of 4 take 1 is root 3. So y take root 3 outside of -1 over root 3 x minus 1. So then we get negative x over root 3 plus 1 over root 3. We get y take root 3 there. Awesome. And then continuing along that vein, y is equal to negative x over root 3 plus 1 on root 3 plus root 3 is 4 root 3 on 3. And we're actually going to rationalize this denominator as well, which means that we get 4 root 3 over 3 minus root 3 over 3x. Now this is our equation of QR when p equals 1. Okay, so our first mark comes when we recognize the equation formula and we sub this in, and then our second mark comes when we actually find the equation and write that as our final answer. So guys, that's it for part AII. Let's move on to part AIII. This next part asks us to find the area of the shaded region when p equals 1. Awesome, and this is also a 2-mark question. So, we know that when p equals 1, our line has the equation y equals 4 root 3 take root 3 on 3x, which means in order to find this shaded region here, so this part in between here, we're going to find the area under this triangle here, and then we're going to minus the area of the quarter circle, right? Because this is a quarter circle, this is a triangle, so our total area is equal to the triangle minus the circle divided by 4, right? Because it's a quarter circle. So we know that our circle has a radius of 2, so that's all good. But to work out the area of the triangle, we're going to need our base and our height, right? Half base times height minus pi r squared over 4. And in order to figure out our base, we're going to need to find our x-intercept of our QR, which means that we're going to let y equal 0. So coming from this equation here, we get 0 equals 4 root 3 over 3 minus root 3 x over 3. Therefore, 4 root 3 over 3 equals root 3 over 3x. So then, x is equal to 4. Alright, so this point here is 4, 0. Sweet, so we know that our base is 4 units long, and in order to find our q value, or our y-intercept, we let x equal 0. Right, so y, just using this formula again, y equals 4 root 3 over 3 minus, this time 0 is just 0, so y equals 4 root 3 over 3. So this section here is 0, 4 root 3 over 3. Fantastic. So now for our area. So we know that our base is 4 and our height is 4 root 3 over 3, which means that we're going to get 1/2 times 4 root 3 over 3 minus pi times 2 squared over 4. Right, so our radius is 2, and our base and height are these numbers here. So then from there we get 8 root 3 over 3 minus pi units squared. So guys, our first mark comes when we get our base and our height for our triangle. So recognizing that this is the formula we need to use and then getting the values for that. Then our second mark comes when we actually get the answer for our total area, which is 8 root 3 over 3 minus pi. Awesome. Let's move on to part B. Part B is, again, we're going to be finding the shaded area, but it's just a little different this time. So this is actually a 3-mark question. What the question says is, the area of the shaded region on the graph above is the area bound by line QR, the circle, the y-axis, and the x-axis. Find the shaded area, A of P, in terms of P. Awesome. So again, guys, the area is equal to the triangle minus the circle over 4. So we're assuming that we don't know P now, right? So we're finding the area in terms of P, which means that P is no longer 1. We're actually just trying to find a general formula for the area. So in order to find the total area, we're going to need to find our triangle area again, which means we're going to find our x value and our y value in terms of P, right? So before, our tangent of QR, if we hadn't subbed in P, we would have got y equals negative px over root 4 take p squared plus 4 over root 4 take p squared, okay? So we subbed in P early before to get our value for QR, but in this case, if you had kept going without subbing in P, this is what you would have got for the tangent equation. So, same process again. So we need to find our x-intercept, which means 0 is equal to negative px over root 4 take p squared plus 4 over root 4 take p squared. And then from here we can say that 4 over root 4 take p squared is equal to negative px over 4 root 4 take p squared. From here, we're going to end up with 4 equals px. Sorry, that wasn't a negative, that was a positive. 4 equals px, and therefore x is equal to 4 over p. Alright, so in this case, our x-intercept is 4 over p, 0, so it's no longer 4, 0. In the other one, p was equal to 1, which meant that 4 over 1 was our intercept, which was 4. So that's all good. So x equals 4 over p, that's our first mark, finding that x-intercept there. So now we're going to need to come up with our y-intercept, right, which is where x equals 0. So y is equal to negative p times 0 over root 4 take p squared plus 4 over root 4 take p squared. This time 0 is all 0, which means that our y-intercept is 4 over 4 take p squared. Awesome. That's our second mark, right here. So from here, we can simply now sub into our formula. So we know that our total area is the triangle, which is half times base times height, minus our circle, which is pi r squared over 4. Well, it's a quarter circle. Now, our base is 4 over p, and our height is our y-intercept, which is 4 over root 4 take p squared. Awesome. Minus pi times 2 squared over 4. Fantastic. So from here, we actually get 8 over p root 4 take p squared minus pi unit squared, well, a of p. So we probably shouldn't say unit squared, that's a function. So that's our third mark. So now we've got a function for a of p in terms of p. That's our third and final mark. So let's move on to part C. Part C is also a 3-mark question and asks us to find the value of p for which a of p is a minimum and state this minimum area. So we know that from our previous question, a of p is equal to 8 over p root 4 take p squared minus pi. Now, our minimum area is going to occur when the derivative of this is equal to 0, right, where there's a stationary point. So we're going to need to find out a dash of p. We can use our CAS in this question. We originally had it so that you couldn't. So if yours says that you can't use the CAS, just try it. Before watching this video, try it without using a CAS, because it was meant to be with CAS. So a dash of p is equal to, according to our CAS, 8 over 4 take p squared 3 on 2. Now you can do it without your CAS, it's just going to take a while. Minus 8 over p squared root 4 take p squared. Awesome. And then from here we know that this needs to be equal to 0 because it's at a stationary point, which means that this is now our first mark. So recognizing that we have to let our derivative equal 0 is our first mark. Then from here we can rearrange this to get to, this can add to the other side, which means we get 8 over p squared root 4 take p squared equals 8 over 4 take p squared to the 3 on 2. Awesome. From here we can actually cross multiply and cancel out our 8's, which means we get 4 take p squared 3 on 2 equals p squared root 4 take p squared. Awesome. Now we can keep going with this, and what happens is we actually get p squared is equal to root 4 take p squared to the 3 on 2 over root 4 take p squared. So we're just dividing both sides by root 4 take p squared. Now this is 4 take p squared to the power of 3 on 2. This is 4 take p squared to the power of 1 on 2. They cancel to give us 4 take p squared. From here we get 2p squared equals 4, p squared equals 2. So therefore p is equal to plus minus square root of 2. But because p has to be greater than 0, p is equal to root 2. Awesome. So this is our second mark, finding out what p is, right? So the question asks us find the value of p, but now we need to state the minimum area. So we know that the area is equal to 8 over p root 4 take p squared minus pi. So subbing in our value for p of root 2, we get root 2 times root 4 take away root 2 squared minus pi. So we get 8 divided by root 2 times root 2 minus pi. 8 over 2 minus pi, which gives us 4 minus pi unit squared, which is our minimum area, a of root 2. 4 take pi unit squared. That's our third and final mark, guys, and that's the end of MM244. If you have any questions, please hit me up in the comments below. But otherwise, thanks for watching and have an awesome day.